স্যার এখানে প্রবলেমটা
বিসমিল্লাহির রহমানির রহিম। হ্যাঁ রবিন, কিছু বলতেছি না
স্যার, এখানে প্রবলেম হলো ইফেক্টিভ ফোর্স এগুলো দেওয়া আছে তো স্যার কনফিউজ হয়ে যাচ্ছে আমরা।
হ্যাঁ
শুধু
আমি বুঝাই দিচ্ছি যে ইফেক্টিভ ফোর্স থাকলে আসলে বিষয়টা কি হবে, মানে চেঞ্জটা কোথায় হবে। ঠিক আছে, দেখো নরমালি আমরা ফলিং বডির জন্য যেটা স্টাডি করি সেটা কিন্তু আমরা এটাকে কনসিডার করি যে ফ্রিলি ফলিং বডি, ইট ইজ আ ফ্রিলি ফলিং বডি। আমরা ফলিং বডির যে স্টাডি করছি না, গ্যালিলিওর ল। তো গ্যালিলিওর যে ল গুলা এগুলাও আসলে ফ্রিলি ফলিং বডির জন্য। ফ্রিলি কথাটার মানে হচ্ছে এই বডিটার উপরে গ্র্যাভিটি ছাড়া অন্য কোনো ফোর্স কাজ করতে পারবে না। কিন্তু আমরা জানি যখন আর্থের মধ্যে এরকম কোন একটা বডি পড়ে সেখানে এয়ার রেজিস্ট্যান্স কাজ করে। তো অনেক সময় আমরা এয়ার রেজিস্ট্যান্স এটাকে নেগলিজিবল ধরে নিই, বাট যদি এয়ার রেজিস্ট্যান্সটা অনেক বেশি হয় তখন কিন্তু আর এটাকে নেগলেক্ট করা যায় না। তো তখন আর এটা ফ্রিলি ফলিং বডি হয় না। ঠিক আছে, তো তাহলে ফ্রিলি ফলিং বডি না হলে, নর্মালি ফ্রিলি ফলিং বডি হলে এটার উপর ইফেক্টিভ ফোর্স কত, এটার উপর ইফেক্টিভ যে ফোর্সটা সেটা হচ্ছে ডাব্লিউ ইকুয়াল টু এমজি, যেটা কিনা হচ্ছে এই বডিটার ওয়েট। এটাই হচ্ছে ইফেক্টিভ ফোর্স। এবং এইটার জন্য যে এক্সিলারেশন ক্রিয়েট হয় সেই এক্সিলারেশনটা কি, জি, এক্সিলারেশন ডিউ টু গ্র্যাভিটি। ওকে, 9.8 মিটার পার সেকেন্ড স্কয়ার। বাট যেহেতু আমাদের এখানে কেসটাতে বলে দিছে যে ইফেক্টিভ ফোর্স অন্য কিছু, তার মানে কি এখানে শুধু ওয়েটটা ইফেক্টিভ ফোর্স না, এখানে ইফেক্টিভ ফোর্স অন্য কিছু। ঠিক আছে, এবং সেই ফোর্সটা তোমার দেয়া আছে। ওকে, তো এটা দ্বারাই আমরা বুঝতে পারি যে এই বডিটা, এই যে বডি যেগুলো পড়তেছে এখন এখান থেকে, দে আর নট ফ্রিলি ফলিং বডি। ঠিক আছে, দে আর নট ফ্রিলি ফলিং বডি। তো তাইলে এই যে ইফেক্টিভ ফোর্সটা যদি চেঞ্জ হয়, এখানে ডাব্লিউটা যদি চেঞ্জ হয়ে অন্য কিছু হয়ে যায়, তাইলে জিটাও আসলে চেঞ্জ হয়ে অন্য কিছু হয়ে যাবে। কারণ জিটা আমরা তখন ইউজ করব যদি এটা ফ্রিলি ফলিং বডি হয়। দেখো আমি কিন্তু তোমাদেরকে বলে দিচ্ছি যে কোথায় চেঞ্জটা আসবে। Freely falling body ক্ষেত্রে the effective force is the weight of the body, and for that we will use acceleration due to gravity. But in case it is not the weight which is effective force, if the effective force is something else, then we have to write F equal to ma. Okay, now the acceleration is not acceleration due to gravity, it is something else. Okay, so we need to calculate this acceleration due to gravity from the effective force which is given. And mass is also given, as you can see. But the thing that seemed a little bit confusing to me is that they did not mention whether it is 10 gram or 10 kg, 20 gram or 20 kg. So for our convenience, as they did not mention, we have the liberty to consider it whatever unit we want. But you have to make sure whatever you consider them, both of them should be same. Like you cannot consider this one 10 gram and that one 20 kg. If you consider this one 10 gram, this is also 20 gram. If you consider this one 10 kg, that one also 20 kg. Okay, so same unit has to be maintained. So let us say we are considering 10 kg. Okay, because if you consider 10 gram, then there is another issue of converting it into kg. So let us not go through that. Okay, as we have open it, as we have the liberty to choose, so we will choose the one which makes the work easier for us. Okay, so understood. Is this one clear? That effective force, as this is mentioned, from here we need to find out the acceleration due to gravity A. Okay, so let us do that. For M1, it should be F1 into MA1, sorry, M1A1. Okay, so the effective force which is given is 0.078, and the mass is given as 10 kg, and from here we can easily calculate the acceleration of the first body. So the acceleration will be 0.078 divided by 10. So the answer will be 0.0078. একটা zero right এ চলে যাবে decimal, left এ চলে যাবে decimal টা. So it will be meter per second square. And for the second body, we can consider, actually I should have mentioned comma দিয়ে এখানে একটু লিখে দেওয়া দরকার ছিল, that I'm considering this one as F1 and comma দিয়ে এটা আমি ধরতেছি F2. Okay, so নোটবুকে লেখার সময় এভাবে লিখে নিও. So F2 will be equal to M2 into A2. So effective force is 0.039 is equal to mass is 20. So into acceleration due to gravity, we have to calculate it. So can somebody calculate and let me know the answer? A2 will be equal to 0.039 divided by 20. Anyone is carrying out the calculation?
Sir, 1 minute, sir. I'm going, sir. Sir, is coming 0.00195. Excuse me,
How
sir.
much? 0 point?
The 0.00195.
0.00195, right? Okay. So this is meter per second square. Okay. Now we have the acceleration due to gravity. Now what we have been asked to calculate, which object will reach ground faster? So they have been released. In the question it is mentioned that they have been released from the same height, and the height is given as 50 meters. So we know that both will start falling towards the ground as soon as they are released. So which one will reach the ground faster? So it depends on time. Okay, so let us say the time taken by the first body is t1 and the time taken by the second body is t2. So we will calculate t1 and t2 and we will check which one is smaller. The body which will have less amount of time to reach the ground will be reaching the ground faster, right? So let us our target is now to calculate t. So which equation can we use? If you notice, we can use this equation. H is equal to ut plus half a t square, right? Now for the first body, what we can do? We can consider h is actually same for both of them, right? So we do not need to consider h1, h2, h is same. But initial velocity u, this is also
Excuse me,
same
sir.
for both of them. Bolo?
স্যার আমরা এইচ এর প্লাসে কি এস ধরতে পারি আর কি, নাকি কোশ্চেনে যেটা দেওয়া
ফলিং
থাকবে
বডির
সেটাই?
জন্য আমরা এইচ ধরি, তো অসুবিধা নেই, তুমি চাইলে এস ধরতে পারো, কিন্তু সেটা কোন ক্ষেত্রে, যখন কোশ্চেনের মধ্যে বলে দেয়া নাই। বাট এখানে কোশ্চেনের মধ্যে ক্লিয়ারলি দে হ্যাভ মেনশন দ্যাট h is equal to 50, so you don't have any option. Okay, so we have to consider h here. Okay,
ওকে স্যার।
okay, so h is the covered distance, not height from the ground. Okay, so when both of them will reach the ground, they will have covered 50 meter each, right? So to cover 50 meter, how much time they need? Okay, we are considering this one t1, this one is a1 t1. U and h is same for both of them. Both of them will cover 50 meter, and both of them are starting from rest, so u is 0. So we can replace the value 50 equal to 0 into t1 plus half into a1. A1 we have already calculated here, so 0.0078 t square. So from here, what we can write, t1 square is equal to 2 will be multiplied with 50. So 50 into 2 and 0.0078, 0.0078. Okay. So from here, if I want to find out the value of t1, then I have to do root over. So what should be the answer? 100 divided by 100 divided by 0.0078. So this gives us
So much. 12,820. 12,820.51.
12,820.51. So do the root over and find out the value of t. If you take root over, then what will come?
113.22.
100?
13.22.
113.22. Okay, 113.22. Okay, so this is second. So this much amount of time the first body will take to reach the ground. Now we will calculate the same.
Sir, you can
Yes.
write 2, 3.
Okay, no problem.
113.2.
Okay, no issue. Acha. Then t2, for t2 we will again write h is equal to u t2 plus half a2 t2 square. So again 50, 0 into t2 plus half into acceleration is 0.00195 t2 square. So from here t2 square will be equal to 2 into 50 and then divided by 0.00195. This doubt was asked by Nahrin. Nahrin, are you there?
Yes, sir.
So T2 will be equal to root over. Can you do the calculation and let me know the answer? Root over
Sir,
ভিতরে
root over এখানে লেখাতে হবে 51282
51282
2.05
0.25
050.
05. Okay, so if you do the root over, then how much will be the answer? Definitely it will be greater than the previous one, right?
Sir, 226.46.
226.46 seconds. So which one will reach the ground faster, this one or this one? Which one?
Sir, T1 means fast
One.
object.
The first object, right? Because it is taking lesser amount of time to reach the ground, so it will reach the ground faster. So we need to write as T1 is smaller than T2, the body with mass, with mass m1 will reach the ground faster. Anybody has any doubt?
No, sir.
Okay, so then we can move to the next problem, right? Okay, the next doubt was, yeah, this one. We had two body, mass m1 and m2, 8 kg and 4 kg. Their initial velocities were given, okay, and they were moving along a straight line. So if we draw a figure, actually I suggest you to draw a figure always, because that makes it clear that you have understood the scenario. So mention this one as m1, this one as m1, and this one as m2. So both of them were running, u1 and u2. Their initial velocity is given. So u1 is equal to 15 and u2 is equal to 10 meter per second. Okay, so now after some time, what happened? They collided. Okay, the bodies collided. So m1 is this one, m2 is this one, and we know that during the collision they will apply force on each other, right? And after the collision, what happened? The first body started to move. The first body started to move with a velocity v1 equal to 10 meter per second. Okay, now the velocity of the second body, it is not mentioned. v2 is equal to what? This is not mentioned. Acha. So now we need to know the impulse of force. This has been asked for the first body, right? If I will open the question again. Find the impulse of force of the first object. Yes, impulse of force for the first object. So we will focus on first object now. Okay, 7C. You have asked doubt 7CD. So 7C I will discuss first. Now impulse of force is actually what? Impulse of force is the product of, can anybody tell me what impulse of force is equal to? What product of? Division class পড়াইছি তো, বলতে পারা উচিত। দুঃখ force and time of application of force, F into T. Now we do not know the force applied. We do not know for how long the collision took place. We do not know if these two things. Then how can we calculate impulse of force? This is a little bit puzzling for the students. But if you remember, while teaching impulse of force, I told you that it has a relationship with the change of momentum. Do you remember what is the relation? Impulse of force. This was equal to the change of momentum. Equal, okay? They are equal to each other. So it is equal to change of momentum. So now if I calculate the change of momentum for the first object, then I can say that that is the impulse of force for the first object. So let us do that. Acha. So change of momentum is actually final velocity m1 v1, sorry, final momentum minus the initial momentum. Sorry, one হবে first object na, m1 e1. So now if you want, you can take m1 common, so it will be v1 minus u1, and then you can replace the value. M1, it is given 8 kg, so we will put 8. Final velocity of the first object is 10, so 10 minus u1. U1 is 15 here, so okay, so 8 into how much? Minus 5. Okay, so minus 40. So as impulse of force, it is the product of force and time. That means Newton and second. So it's easy for us to write the unit also, Newton second. Okay, if you have the basic, actually these are not a problem. Okay, so some might be wondering, sir, what does the minus denote? The minus denotes that the change of momentum was negative. That means that momentum dropped. The momentum did not increase. We can see that the velocity has decreased, right? For the first body, we can see the velocity has dropped from 15, it has dropped to 10. So as a result, there is a drop of momentum. So negative indicates that it has decreased. Momentum has decreased. Okay, so that will be the change of momentum. Now, if we discuss about D, in D, they have asked whether the kinetic energy in case of two objects will be conserved or not. See, whenever they are asking something is conserved or not, all you have to do is show them the amount that they have mentioned. It has not changed before and after collision. Like they have asked about kinetic energy, right? So we need to calculate kinetic energy for the first body before, you know, what should I say? Before the
Collision.
collision, yeah, and after the collision also. But generally, but will the kinetic energy be conserved in case of two objects? The question is actually a little bit confusing, because normally what they ask, the total energy, kinetic energy is conserved or not. So in that case, we calculate the kinetic energy for both of them before the collision and add them up. That will give us the total kinetic energy. And after the collision, again, we calculate the kinetic energy. So that gives us the total kinetic energy after the collision. So if they are same before and after, if they are same, then we say that the kinetic energy has been conserved. But now here they have they did not mention total kinetic energy. They are saying, will the kinetic energy be conserved in case of two objects? I think they have mentioned about the they are indicating about the total kinetic energy. Okay, so considering that, inshallah, we will show if the kinetic energy remains same or not. So to do that, we need the velocity before the collision, after the collision, which is available for the first body. But for the second body, you can see that the final velocity is not known, right? So to find this final velocity, we need to apply conservation law of momentum. Okay, conservation law of momentum is what? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So if we apply this one, we will find out V2 from here. So M1 is what? 8. U1 is 15 plus M2 U2. M2 is 4. U2 is 10 equal to M1 is 8. Yes, V1 is 10. Bolo. আলিমা কিছু বলবা?
দেখা যাইতেছে না।
আমার লেখা দেখা যাচ্ছে না? স্ক্রিন দেখা যাচ্ছে না?
হ্যাঁ, এখন আসছে।
তোমার ওখানে বোধহয় একটু পড়ে গেছে। ওকে, 80 plus 4 V2. So from here we will calculate V2. 120 plus 40, that gives us 160, and from that we will subtract 80 equal to 4 V2. So V2 will be equal to 160 থেকে 80 গেলে 80 থাকে, আর 4 যেটা মাল্টিপ্লাই হচ্ছে ছিল সেটা ডিভাইড হয়ে যাবে। So V2 will be equal to 4 into 20 না, তাহলে 20 meter per second. So we have V2. Now we will calculate the kinetic energy before and after the collision. Okay, so before collision, total kinetic energy. ek is equal to ek1 plus ek2। আচ্ছা, এটাকে ek দিয়ে রিপ্রেজেন্ট করার দরকার নেই, এটা ডাইরেক্ট আমরা ek1 ek2 লিখতে পারি। এটাকে আসলে আরেকটু স্পেসিফাই করতে হবে, বিকজ ইনিশিয়াল এন্ড ফাইনালের একটা বিষয় আছে, তো তাহলে আমরা এটাকে যদি আরেকটু স্পেসিফাই করে লিখি তাহলে এভাবে লেখা যায় ek1i ফার্স্ট বডির ইনিশিয়াল কাইনেটিক এনার্জি and ek2i second body initial kinetic energy. So how can you calculate? Half m1 u1 square half m2 u2 square. So here just put the value. How much? 8 into u1 square. তোমরা একটু আমার সাথে সাথে যদি বলতো আমার জন্য একটু ইজি হইতো, বাট তোমরা জানি না কোন দুনিয়া থাকো। আচ্ছা ওকে, 4 into 10 square। তো তাইলে এখানে আনসারটা কত হয় সেটা একটু তোমরা বের করে ফেলো। দেন আমি আফটার কলিশনের জন্য কি হবে সেটাও এখানে লিখে ফেলতেছি। আফটার কলিশন এটা হবে ek1f final and ek2f final. Okay, so here it will be half into m1 v1 square plus half into m2 v2 square. So here also we will replace the value. M1 is 8 and v1 is 10 plus half into m2 is 4 and v2 we have found out to be 20. So 20 square. So kindly calculate these two quantity. আপনারা কি করবেন নাকি আমি করে ফেলবো?
Sir, first একটা 1100.
1100. Okay, so this is joule because we are calculating kinetic energy. The second one
1200.
1200 kinetic energy conserved হয়নি। Okay, anyway, যেটা আসছে আমরা তো সেটাই লিখবো। তো তাহলে 1200 joules. So we can see that the kinetic energy has not been conserved. So you will write as we can see. ঠিক আছে, ফাইনাল লাইনটা কি লিখতে হবে সেটা আমি একটু এখান দিয়ে লিখে দিই, যেহেতু ওখানে আর জায়গা নেই। ঠিক আছে, এটার পরে আমি একটু এদিকে ইন্ডিকেট করে দিচ্ছি। এখানে লিখতে হবে কি as ek। টা তোমরা ডিটেইলস লিখবা যে kinetic energy before and after collision aren't equal. So kinetic energy has not been conserved, has not been conserved. জেনারেলি কাইনেটিক এনার্জি কনজারভেশন এটা এসএসসি লেভেলে দেয় না। কেন দেয় না? কারণ এটা হচ্ছে এইচএসসি লেভেলের টপিক। এইচএসসি লেভেলে তোমরা একটা জিনিস পড়বা যেটাকে বলা হয় ইলাস্টিক কলিশন এন্ড ইনইলাস্টিক কলিশন। ইলাস্টিক আর একটা ইনইলাস্টিক। ঠিক আছে, তো কখন আমরা ইলাস্টিক কলিশন বলবো, কখন ইনইলাস্টিক বলবো? যখন কাইনেটিক এনার্জি কনজার্ভড হবে তখন বলি ইলাস্টিক কলিশন, আর যখন কাইনেটিক এনার্জি কনজার্ভড হবে না, যেটা কিনা আমাদের কেস, তো তখন আমরা ওইটাকে বলি inelastic collision. So in our case, what is it? Elastic or inelastic?
Inelastic.
Inelastic collision, because the kinetic energy has not been conserved. Anybody has any doubt?
No, sir.
Okay. So we have exactly 2 minutes left. Acha, let us try to solve at least C. Okay, এটা হচ্ছে কত? 9 number, 9 এর C. So we know that F is equal to ma. Now when we will write only F? When there is only one force acting on it. But in the question you can clearly see that they have mentioned two forces are acting. One force that we are applying and another force is the frictional force. Whenever our body will try to move on a surface, definitely that surface will apply some will offer some friction, right? So in such case we will give summation of force is equal to ma. Okay, so now summation of F means here two forces are acting. One is F, another one is small f. One F, capital F is what we are applying, and small f is frictional force. So equal to ma. Now, capital F, this is something we have to calculate, and the small f, it is given 10 Newton. We will consider this one to be minus 10 Newton because, if force is being applied in that direction, the frictional force will definitely be applied in the opposite direction. So that is why it is minus 10. Equal to mass. The mass is given as 5 kg. Now, acceleration, this is something unknown to us. So can we calculate it? It seems that we do not know the time, so from here we cannot calculate. But when time is not given, then there is an equation which you can use. You can see that using this equation we can easily calculate acceleration because v is needed, we know the v, u is needed, we know u, and s, that is distance, that is also given. So from here you will calculate a, right? After calculating a, you will put the value here, and then you know all the value except capital F, so you can calculate it. Abdullah, you asked this question. Is it clear how to do it? Can you do it,
Yes, sir.
inshallah? Okay. So about D, we will discuss in the next class. Okay. Because we have less than 1 minute left.
Okay.